Hi guys, so today we're given the problem, determine the horizontal and vertical components of reaction at the supports. Neglect the thickness of the beam. So first in this problem, let's start by identifying what the reaction forces actually are in this picture that we're given. So at the first point, at point A, there is a pin joint. So for a pin joint, it has both an x and a y component. So we have a of y right here, and then let's draw our x component, which I'm going to label as a of x. Next, let's take a look at point B. Point B has a roller joint at it, so it's only going to have a y component. So that is going to be b of y. Now that we've identified what the reactions at each of the supports actually are, let's start by creating our equations of equilibrium. So for these equations of equilibrium, we're going to do sum of the forces in the x, y, and then the sum of the moments about really any point that you want. So first I want to start out with the sum of the forces at the x, being that there's only one reaction force in the x direction, a of x. So sum of the forces in the x equals 0. And let's draw that out. So we have the a of x component right here. And then we have that 500-pound force, this one right here. And that one is you're going to use that triangle and use the sine and cosine identities. So it is going positive in the x direction. And it's going to be 500 pounds. And it's going to be multiplied by 3/5 because it's x. So you're going to be using the cosine or the adjacent side to it, and set those equal to zeros because that's all the forces you have in the x direction. Let's go ahead and just solve for that right now. So a of x then is going to be equal to negative 300 pounds. And that is our answer for the support reaction at a of x. Next, I want to move on to the sum of the moments at point A. And let's do it at point A because it'll just be simpler in taking out the a of x reaction force as well. You can do it at point B if you want. It'll just add a little bit extra to that equation. So I'm going to do it as counterclockwise positive, and then sum of the moments at point A is equal to 0. So now we're going to get that is going to be negative 600 because you have that 600 pound per feet moment created right here. So it's going clockwise, so it's going to be negative because we established counterclockwise positive. Then add on to it the b of y force, that reaction force we identified. It's 10 feet away from point A, so multiply on that 10 feet to find out its moment. And then next, the last force we have is that negative 500. I'm going to be using the y component of that 500 force. So it's going to be multiplied by 4/5, the opposite side of it. And then it's 5 feet away from point A. So multiply it on that 5 feet. Set it equal to 0. Let's just chug in those numbers right now. You're going to find out that b of y should be ending up as a 260 pounds. Alrighty. And then finally, we have one last one in our reaction forces. So let's go ahead and do the sum of the forces in the y direction. Set that equal to 0. So we have the a of y reaction force that we still have to solve for. Add on that 260 pounds, which was originally the b of y. And then that 500-pound force is going negative in the y direction. So it's going to be minus 500 using the y direction. So it's going to be 4/5. Because using the opposite side, set it equal to 0. Go ahead and plug in those numbers into your calculator. You should be ending up with 140 pounds. And that is your final answer for a of y. So you have a of x, b of y, and a of y. And these should be the reaction forces that you should be ending up with. Thank you guys, and have a wonderful day.